All right, you guys, we are now tackling example 2, and I promise this time the demon cats won't get me. Like, they're just not. I'm going to make sure they don't since I screwed up last time. So, sorry, you guys, but we made it out alive, so we'll be okay. But anyway, so in example 2, we are now applying the converse of the angle bisector theorem, which is when we reverse the angle bisector theorem. So, the angle bisector theorem states that if a point is located on an angle bisector, it is equidistant, or the same distance, to each side of the angle. So if I reverse that statement, if I have a point that is the same distance to each side of an angle, that means it's on an angle bisector. So in this problem, we need to see if there's a point that is the same distance to the side of an angle. So if I'm looking at example 2, I spot this lovely angle right here. This is an angle. There are several angles in the picture, but I'm going to focus on this angle right here. Okay, so if you guys see here, there's a point. It's not labeled, okay? I don't know. I might label it something just to call it something. I'm going to call it point, I'm going to name it point cat. I'm going to draw a cat face because I love cats. Okay, so this is point cat, and if you see here, point cat is the same distance to each side of this lovely blue angle, which is also not labeled, but that's okay. It is 5 units to this side of the angle and 5 units to that side of the angle. So guess what, you guys? Point cat must be on an angle bisector because it's the same distance to each side of my angle. Holy hot dog, right? So if this point is on an angle bisector, what that means is this ray right here is an angle bisector. So this thing right here is an angle bisector. Whoa. An angle bisectors will slice an angle in half. It will split it in half. And when something splits something in half, guess what, you guys? It will make 2 congruent angles. So that means these 2 angles will be congruent, which again, the angles aren't labeled, but we can make it work. They have numbers within the variables, so that will help me to identify them and to solve for them. Okay, so now that I know these 2 are congruent, that means that their measures are going to be equal. So since they are going to be equal, I'm going to set 4x equal to 2x plus 20 because they're equal. So that is how I'm going to set this thing up to solve for x. So I know 4x will equal 2x plus 20 because the 2 angles are congruent. All right, guys, let's get going. Solve this thing for x. Let's do it. All right, guys, I need to join my x's together, and they're currently separated. So I'm going to move 2x to the other side. So the way I bring a positive 2x over is by subtracting it on both sides. 2x minus 2x cancels and turns to 0. 4x minus 2x is 2x. So I have 2x equals 20. All right, and the 2 and the x are secretly multiplying to each other. So the way that I'm going to get x by itself is by dividing that 2 on both sides. Bam. Which 2 divided by 2 cancels and turns to 1, and 20 divided by 2 is 10. So x equals 10, you guys. Yay! We're doing great. All right, let's keep going. So, not only do I have to solve for x, I also have to find all the angles containing x. So I need to find what this angle is and this angle. Which, since I know x is 10, guess what, you guys? I can substitute in 10 for x, and that will help me to find that angle. So let's do this thing. So I'm going to substitute 10 in for my x. So 4 times 10 will give me 40 degrees. So if I did this correctly and did not let the demon cats get to me this time, that means that this angle, since it's congruent to 4x, these little congruent symbols, all right, that means it should also be 40. So I really hope this time it's 40, because if not, I might cry a little bit. I really don't want to cry right now, and these would not be tears of joy. These would be tears of sadness, because I really don't want to mess up again. But the nice thing about math is if you mess up, you can fix your mistake. So I really shouldn't cry. I really should be better than that. So I'm going to be better than that and try not to cry if I get it wrong. But anyway, so I'm going to substitute in 10 for x right here. All right, let's see, you guys. I'm really nervous. Let's see if I get it right. So 2 times 10 is 20. And guess what, you guys? 20 plus 20 is 40. Yay! So both of these angles are 40 degrees. Pretty cool, right? We have just applied the converse of the angle bisector theorem. Way to go, you guys. One thumbs up. Actually, I'm going to give you 2 thumbs up because you're so awesome. Nice job. Okay, yes. Yes. Rename. I don't want it to open. All right, you guys, we are now tackling example 2, and I promise this time the demon cats won't get me. Like, they're just not. I'm going to make sure they don't since I screwed up last time. So, sorry, you guys, but we made it out alive, so we'll be okay. But anyway, so in example 2, we are now applying the converse of the angle bisector theorem, which is when we reverse the angle bisector theorem. So, the angle bisector theorem states that if a point is located on an angle bisector, it is equidistant, or the same distance, to each side of the angle. So if can I rename it now?